I'd like to bring out Billy Thalheimer, who is the founder and CEO of REGENT, and Chris Thiel, who is joining us all the way from Saudi Arabia from NEOM. Billy's company, REGENT, this concept of the brave new world of coastal transportation. Right now, I think you're sort of a party of one in terms of companies that are pushing this. This is a very intriguing idea where you're sort of blending elements of the eVTOL with sort of a business jet and an airfoil sort of thing. You're operating over water. This is a very new idea, but you seem fairly far along and not that way from a commercialization. So first of all, tell us a little bit about REGENT. What is the concept of your seaglider that you want to introduce?
Sure. Well, at REGENT, we build seagliders. For those of you that haven't heard of a seaglider before, a seaglider technically is a hydrofoiling wing and ground effect vehicle. There's a lot of jargon there. So operationally, it is a wave-tolerant flying boat powered by batteries. So we can unpack that a little bit. 40% of the world's population lives in coastal communities, and so we're really targeting that market. We're doing so with a new take on a flying boat. It's actually recycling a 60-year-old concept called a wing and ground effect craft. Ground effect is a much older concept. Birds have been doing this for millennia. It's that cushion of air that you see birds flying on when they're flying low over the water surface. This dynamic cushion of air gives them aerodynamic benefits, and therefore we get range improvements by flying over it. And that's critical today with our existing battery technology. So myself and the founding team at REGENT, we're working in the eVTOL space. We said the opportunities of this technology are amazing. The sustainability, the low cost, the low noise, the increase of safety. How can we bring this to market in a way that unlocks regional transportation, which is what we were focused on with today's batteries, and it involves this sort of aerodynamic hack of getting extended range. So we are a wing and ground craft. We use hydrofoil technology, so we pull in from the maritime space to give wave tolerance when you think about flying boats or seaplanes or even past attempts at flying in this ground effect before. All of these vehicles have been limited by the wave height. And that's not okay when we're talking about a transformational new technology that you can rely on, that I can take when I go to vacation in Hawaii or NEOM, no matter what the waves are. I need to be able to rely on this, and the operators need to be able to utilize this. So we use hydrofoils from the America's Cup and Sail GP and other sort of modern race yachting endeavors, sort of the F1 of the sailing world, the latest technology there to give us high wave tolerance. We combine that with the latest technology from the eVTOL space, from the aerospace world, to bring a vehicle called the seaglider that is wave tolerant for high cadence operations and sustainable regional travel.
So initially, with your co-founders, were you sort of starting out in the eVTOL direction initially before you decided to pivot?
Well, we used to work for a Boeing subsidiary. Actually, a lot of the founding team were working for Aurora Flight Sciences, which was sort of one of the thought houses that is now powering the Whisk joint venture. So we were deep in on eVTOL. My own background is as an aerospace engineer. So we were very familiar with and enamored with this eVTOL technology. It's amazing that we can fly humans on all electric vehicles right now for so many reasons. But we also kept banging our heads against the wall on really two problems in particular. One is the limited range of this technology, and it was sort of difficult for us to justify, all the time and effort we were putting into developing these platforms that can go that far. A lot of us were based in the Boston, Massachusetts area, and we were thinking about routes like Boston to New York. A huge corridor. You think about LA to San Francisco over here, right? Imagine if we had better ways of doing those routes. Those are regional routes where I'm going to sit in traffic no matter when I leave, and I'm going to sit in the airport for longer than I'm in the airplane, right? So that's sort of the sweet spot, the least comfortable place to be right now. There's no good solution. That's what we wanted to solve. And then the other thing that was difficult was the regulatory pathway. And when we look back through history, we see it taking $1 billion in a decade to certify a new aircraft technology. So we said, why are we going to spend a decade and $1 billion to build a vehicle that can't do the routes that are really causing us the most pain today? And we ended up being able to solve both of those problems in the maritime space. So we left Boeing and started down the startup path, and that was 3 years ago.
So you started 3 years ago, and realistically, what is your timeline for commercialization for delivering the first units that will go into service?
Well, I'll start by saying we have an incredible amount of interest in these units. So over the past 3 years, we've accumulated a backlog of $8 billion worth of orders. We have order holders from all around the world, 6 continents around the world. We are the OEM, we're the manufacturer of seagliders, the Boeing of seagliders, if you will. We sell to the operators, so we have customers who are airlines, we have customers who are ferry operators, we have customers in offshore logistics, commercial logistics, and even in defense. And we have strategic investors like Japan Airlines, Hawaiian Airlines, and like NEOM, who will buy and operate and integrate seagliders into sustainable city projects. So in terms of the timeline to get there, right now we're building our full-scale prototypes. That'll be the first full-scale seaglider that's carrying humans on board with flight plan for next year. And then within the next 2 to 3 years after that, we'll commercialize and deliver to our first customers.
And Chris, you are representing NEOM in this case. You are an investor in REGENT, but you also do plan to put these into operation. Tell us a little bit about how these are going to integrate into what you're developing at NEOM.
Yeah, absolutely. Hi, everyone. Before I start answering your question, I would like to find out who of you have heard about NEOM before. Can you just show a show of hands? So yeah, that's a good 70%. I can give good feedback to our marketing department. Nevertheless, just a little bit of background, right? I mean, NEOM is comprised of 2 words, the Greek word neo for new and the Arabic word mustaqbal for future, so new future. We are a smart and sustainable city development in the northwest part of Saudi Arabia, really, trying to envisage what the future might look like, and also solving the biggest challenge of our generation, which is climate change, without a doubt. In terms of mobility, that means that we are going 100 years back, and we're going to be the first city, first region that is designed around people, not cars, in 100 years. And what we are establishing is the first truly sustainable, seamlessly connected mobility system, which is leading in innovation and the integration of autonomous solutions. This is really based on 4 pillars: shared mobility, active and micro mobility, flexible on demand, and obviously zero emission vehicles, vessels, and aircraft. From my point of view, the future of mobility is multimodal. Over the last day and a half, we had a lot of analogies with dating platforms in this context. So I also prepared an analogy, because in order to get people to opt into multimodal mobility, it's similar of getting people to your dating platform, right? You have to offer connections which are more convenient, more comfortable, and more exciting than other platforms. So we have to offer connections in our multimodal mobility system which are exactly that: more convenient, more comfortable, more exciting. And this is where for us REGENT comes into play, because the latest technologies will really entice people to opt into trying new mobility technologies at NEOM. And we have obviously 450 kilometers of coastline. And when I first heard about REGENT, I have to say I had to Google it, and the first thing that came up was the Caspian Sea monster. If you have not seen the Caspian Sea monster, Google it. Then I was thinking, okay, this thing existed in the 1960s. How come that nobody has been successful in commercializing ground effect vehicles? And then after our conversations, obviously, it is quite impressive. You're not only electrifying the technology, but you're also adding this foiling stage. So it means your vessel is not just floating and flying, so going either very slow or very quick, but also have that foiling stage with about 35 knots, which means it can operate in more congested marina environments. That we also have a lot of it, because at NEOM, we really we try to attract a lot of the super yachts of this world to spend the winters with us in our incredible climate.
So give us a few specs here, Billy, on your initial vehicle that's going to come out in terms of range, top speed, passenger load, that sort of thing.
Sure. So our first seaglider is called the Viceroy Seaglider. It's a 12-passenger vessel, has 2 crew members, or about 3,500 pounds of payload in this configuration. We have some cargo customers as well. So 180 miles at 180 miles an hour, for those who are really good at math, that's about an hour flight. So the amazing thing about sea gliders is the cost, because they're 100% battery electric systems. So you think about the cost of a seaplane as sort of the existing best in class. We're going to start with a small aircraft, which has a very complicated turboprop engine and gears and things you need to lubricate and look at, already very expensive, and you need trained maintenance personnel to look at that engine. Now we're going to take this aerospace grade system and we're going to dunk it in salt water all the time. And so that ends up doubling to tripling the maintenance costs already. And that's why seaplanes are so expensive today. So what we do is we have motors, and we have batteries, and there's one moving part, that's the motor bearing, and that's also sealed. It's completely waterproof. So it is a very simple system. The training in terms of the maintenance cost of it, instead of having to get in and take apart an engine, you just pop off a motor and pop it on again. There's literally 6 bolts, like you can do it in 5 minutes. So you talk about the maintenance cost, which ends up being the driving cost of this short haul flight regime. Over half the cost is in maintenance. And we're reducing that substantially. So at the end of the day, when you bookkeep all the other costs, the vehicle itself, the crews, the docking or the airport fees, we end up halving the cost compared to existing best-in-class small aircraft. So that ends up being on our 12-passenger Viceroy about 40 cents a seat mile. So 100-mile mission, let's say between the islands of Hawaii, for example, you're looking at $40. We're based in Rhode Island, and turns out that Providence to Manhattan is about 180 miles. Our max range, or also Miami to the Bahamas, about 180 miles. So that's about $60. That's it. And so it's incredibly quiet, incredibly convenient, incredibly fast with 0 emissions, and it also happens to be the most affordable solution by far for these transportation. And as Chris is talking about, what is going to incentivize people to try out a new technology? Anytime you're switching technologies or switching use cases, there's some switching costs. People need to become familiar with that. But sea gliders actually win on all axes. They're faster, cheaper, more comfortable, and greener, and that's what it's going to take.
So how about regulatory certification? What is that process like? Certainly, if you're going through the FAA, that's painful and long and expensive.
Yeah, well, we're engineers. The founders were engineers, and my father was an engineer. And growing up, he always used the analogy KISS. I don't know if anyone's heard that slogan before. It stands for "Keep it simple, stupid." So that's what we really did with our with this new concept, was to say let's make everything simple. So instead of using sort of difficult aerodynamics and trying to fly, let's use ground effect where it's easier, and the air is actually helping us. It's a cushion. Instead of having to develop all this new infrastructure, let's use docks. They already exist. In many cases, they're already electrified. Port Miami is already electrified because the cruise ships are coming there. And then also on the certification pathway. So because sea gliders are exclusively over water, dock-to-dock over water, because they always fly within a wingspan of the water surface, you're flying below the height of a sailboat mast. You're looking up at cruise ships as you fly past them. We are very much in the maritime domain, and therefore we're under the jurisdiction of the Coast Guard internationally. And so that's actually very helpful too, because the important things about operating a sea glider are maritime navigation. It's read, write, return. It's how do I navigate and what are the right-of-way rules at sea that's faster to train. And so we can still bring aerospace grade safety and redundancy and robustness into the safety analysis process, and we are absolutely doing that. We're even pulling from FAA guidelines as we develop our flight control systems. But at the end of the day, the Coast Guard agencies are the authorities, and we train our crews not as pilots, but as mariners.
And Chris, in NEOM, how do you envision this operating? Like, is this going to be used mostly for logistical purposes or for actual mobility, for moving people?
No, for moving people. It will be fully integrated with our multimodal mobility system. As I said, 450 kilometers of coastline have to be served, so we need a sustainable technology that can move at speed to connect from one end to the other at times as well. In addition to that, we already have marine infrastructure in planning and in design. That's obviously one of our advantages, that we can we don't have we don't have existing infrastructure, so we can really start from scratch to design and ensure that all our major hubs along this coastline can be served going forward with seagliders as well. So that's what we envisage, and this is also why, obviously, it's not just an investment that we did with REGENT, but it's really a collaborative approach that is very important for us. So from next year onwards, we already send young Saudi engineers to do internships at REGENT, and then in 25, we look forward to do initial hot and harsh testing in our waters to ensure that the technology is also able to operate well in our idiosyncratic conditions. And then from 26 onwards, we really want to have a prototype in the water and prepare for operations, because what we cannot underestimate is that it's not just buying a seaglider and putting it in the water and everything works, but we really have to build the whole ecosystem around it, and this is only possible working together from today.
And it's not just a mobility solution, because I think I saw you're working with the Marines. What's that all about?
Yeah, so we founded REGENT with a commercial focus. How do we reduce the pain and the cost and the carbon footprint of getting from a place like we were in Boston, so Boston, New York, LA, San Francisco, places like that. But what we found was sort of the sort of growing geopolitical tensions are in the Indo-Pacific, and the next potential global conflict is there. And so Allied Defense Strategy is really focusing on how can we affect mobility along island chains. And it just so happens that we build a very inexpensive, very easy to operate, very fast island hopping machine. So while the sort of threat from a existential sort of world peace perspective is frankly terrifying and very not good, from a REGENT sort of strictly product market fit perspective, the timing couldn't have been better for us. So we are a dual use company. We are working with the United States Marine Corps now, and in conversations with allied forces as well, supporting that mission in the Indo-Pacific. Specifically, and the one we're focused on now is the high-speed logistics mission, which is crew and cargo between island chains, supporting what's called expeditionary advanced space operations, which is moving from island chains very quickly. It's almost a World War II style, which we haven't done in a very long time, but moving things around island chains. But the value proposition is really the same as on the commercial side. These vehicles are very easy to operate, very easy to crew, so it's easy to train. They're relatively inexpensive, both to purchase and to operate. The quietness that is amazing on the commercial side also means a relatively low signature, and therefore easier to protect the inhabitants on the defense side. So, we can sell the same widget to our commercial and our defense customers, and our investors have looked very favorably upon that as well.
And I guess my last question before we open it up, the battery system that you're using, it's going to be a fairly conventional lithium-ion system like we would find in the EV market. Just to sort of put this in terms I can understand, how many Teslas worth of battery are you sticking in this thing?
Yeah, I think we're about at maybe 7 Teslas or so. It depends if we're talking extended range or not, but roughly 7 Teslas. It's a big craft. It's 12 people.
Right. And that's it's 3,500 pounds with passenger and/or cargo combined.
Correct. Yeah.
Okay.
Yeah.
We've got a few minutes. Do we have any questions from the audience? I guess we do.
Yeah, I can start. Thank you. NEOM is also an investor in Volocopter. And so I'm just kind of curious what the range and when do you start competing with Volocopter? They have the VoloCity, which is like 1 passenger after 2 seats. And it's going to go to the Paris Olympics next year, hopefully US in 25. But they won't compete with 12, right? And I live in the Seattle area. You heard of Kenmore Air?
Of course.
And they have de Havilland otters and beavers, and man, are they noisy. And they fly into this lake right by downtown Seattle. And then they fly, up in the islands, which you don't appreciate the noise there either. So this seems like a good option, but that's about 100 miles away. Too far for a VoloCity, maybe the Volo Connect, but that's what, 3 or 4, depending on how you look at it. And now you're 12. So can you get in a Volo Connect for 3 passengers for the same price as yours at 12, And how often do you need to go back and forth? How do you compete with, you have investor in both. How do those two things compete? And at what range?
So for me, there's no competition, right? That's different transport routes, or however you want to call it. I mean, here we talk about, brave new world of coastal transportation. So that's really only possible over water, right? I mean, the seaglider can only operate over water, whereas obviously, other technologies such as, our volocopter investment is, point-to-point transportation over land, sea. So it's a bit different in that sense. So purely water to like routes that go over water only, that would be seaglider routes. But then we have a number of other routes which will, encompass also landmass, where obviously REGENT cannot operate.
Well, that's why I mentioned this particular route from Seattle to Orcas Island. And then to Vancouver is almost 200 miles. Victoria is probably less than 100 miles. So, and it's all water. I mean, you can land in all those places on the water, right? So how does that compete when you do have a water range or water landing?
Yeah, to Christian's point, we also don't view it necessarily as competitive. There are a few routes in the world where fast ferries compete with small aircraft.
Victoria.
And it happens, we do very well on those routes. If it's over water, we do very well. But, to Chris's point, we do things that eVTOLs can't do. We can go much longer range. We can carry more cargo, and our prices are less. However, they do things we can't do. We're not going over land. So we're designing our systems to be collaborative with eVTOL systems and electric car systems and everything else that we're electrifying in these multimodal futures. We're going to share the same chargers with the same charging standards. It is very possible that you fly into NEOM on a long haul aircraft, get out into your Volo city to fly from the airport to the coast, and then hop in a seaglider, which is charging at the same charger stand to go on out to your final destination.
Yeah, sounds great.
So I was familiar with the fact that you go on kind of a maritime law and Coast Guard. Given that you're under the height of a sailboat mast and also going at 180 miles an hour, how do you manage, I guess, routes or lanes, and is there advanced sensing equipment that you have to see what's ahead of you?
Absolutely, and that's one of the primary distinctions between a sea glider and past attempts at wing and ground craft like the Caspian Sea Monster. If you look back through it, I definitely encourage the Wikipedia deep dive. It's an hour of your life that you will not regret. You can see they're plagued by failures and crashes, and that's because they were all human operated. So you have the pilots of these vehicles controlling them in all directions, basically holding them at this low altitude, so almost like you're landing the plane for the entire flight. And that is the most intensive part of flying a plane, and it's totally unviable. But we have systems now that can control this. All of the advanced flight control systems that are going into eVTOLs, balancing these inherently unstable craft in all conditions, we can put in ours to control the craft as well. And REGENT's sort of additional proprietary secret sauce is being able to look down and gauge our altitude off the water, even in a wave state. So even if it's not smooth, we know where we are, we can control the craft. And we actually abstract away all the difficult parts of flying the craft, so that all the captain's doing, because these are maritime captains now, are driving it like a boat. So your only controls are left and right, fast and slow. It's all two-dimensional. When you're on the surface of the water, it's obvious. When you're in the air, it's still two-dimensional. You just happen to be 20 feet off the water, but you're still driving like a boat. And so to enable the captain now to see ahead, because now we are in the maritime environment, moving faster than anything else in the maritime environment, we have a very robust sensor system that is monitoring ahead, sweeping forwards with radar, sweeping forwards with computer vision, superimposing that with AIS, which is the transponder system in the water, delivering that sensor fusion system to the captain, and then we have a human captain at the end of the day who's looking out and making those detect and avoid decisions. So the point of abstracting away the low-level flight controls is that's not what humans are good at, making micro reactions and controlling a vehicle. Machines are great at that. What humans are good at is navigating and communicating and looking outwards. So in our context, that's what they're going to be doing 100% of the time.
Do we have one final question? We'll take one more.
Yeah, quick one. So, Billy, you mentioned customers across 6 continents. And how do you approach the scale-up and the manufacturing of the crafts? Are you looking to have hubs around the world, or one big facility and then ship them around? What's the strategy?
Yeah, so we're planning on starting our manufacturing in Rhode Island, where we're based today, and sort of spooling up our ramp rate in a way that makes sense, both for our final integration centers and also our primary suppliers. So we're not the fully integrated OEM like some of the eVTOL ones are. We do have some primary suppliers across our components, so we're working with them to determine sort of reasonable ramp rates. But then as we do get to scale, it definitely makes sense to have hubs in other parts of the world, and that's one of the exciting things with NEOM and some of our other partners in the Middle East too, is that middle part happens to be a very important part. It is very geographically centered between Europe and the Middle East and on down into Indo-Pacific, where we have other customers and interests. So a sort of manufacturing hub, integration hub, support hub, training hub in that region would make a lot of sense for us.
Great. Well, I think we're at time. I am definitely intrigued to see these out there, and maybe you'll have them set up in Long Beach, and we can go out to Catalina or down to San Diego a lot faster. Thank you for your time.
Thanks,
Thank you.
Thanks, everyone.